Hello everyone, I hope you all are doing great. In this video, we will focus on the hard category question from CodeBash 2.0 Senior Division. The name of the problem is VIT Friends. Now let's see what's in this problem. The problem states that VIT Pune has started its own social networking site where there are n users. These users can either be friends with each other or have blocked each other. This means if a user A is a friend with user B, then user B is also a friend with user A. There is a bidirectional relationship. Similar goes with the blocked relationship. As soon as you read these two statements, immediately you realize that we'll be using graphs to solve this problem. Now let's see what the problem further states. In all of the n users, there are s friends relationship, there are s friendship relationships, and there are total t blocked relationships. In order for a user E to be in friend suggestions of user F, all of the following conditions need to be satisfied. E and F are not already friends. E and F are not blocked by each other already. And the third line states that no, there should be a traversal path between E and F. That means there should be a way from E to F to traverse. Now let's see what we have to find. For each user I, we have to find the total number of possible friend suggestions the person can have. Let's see the input format. The first line contains three integers, nst, n the number of users, s the number of friends relationship, and t number of blocked relationships. The next S lines contains the nodes which are friends with each other, and the next T lines contains the nodes which are blocked by each other. These are the constraints, and this is the first sample input. Now we'll see in detail how the answer comes 0101. Now let's see the first sample test case and find out how the answer comes 0101. Let's see the input. The input states there are four number of nodes or four people. There are four friend relationships and there is one block relationships. The first four line contains the people or the nodes which are friends with each other. Now this is the graphical representation of this input case. For now 2 is friends with 1 is friends with 3 is friends with 2, and 3 and 4 are also friends. However, the last after the four lines, there are total t blocked cases, which is only one here. Now 4 is blocked by 1 and 1 is blocked by 4. Now let's look up to the output, how it comes to be 0101. For the first node 1, it is connected to 2, it is friends with 3, but it is not friends with 4. However, 1 has blocked 4, so there is no chance that 1 can be a friend of 4. So there are 0 possibilities for 1 to be a friend of any other node remaining. Now for the second node is friends with 1, friends with 3, but not with 4. 2 has not blocked 4, nor he is a friend of 4, but we can traverse from 2 to 4. So this satisfies all the three conditions to be a friend candidate. Therefore 4 is the friend suggestion for 2. Keeping up the answer 1, that is the total number of possible cases. Now move on to 3. The node 3 is connected to all the other nodes. That means there is no other node left for 3 to be a friend suggestion. Therefore the answer is 0. Now move on to 4. As we have seen, 2 is a friend suggestion for 4. Similarly, how we found that 4 was the friend suggestion of 2. Therefore the output is 0101. Now the simple logic to find this answer is friend suggestion for every ith node equal to the total number of other people in the same check set. We'll see what this check set means in a minute. Minus the number of friendships corresponding to the person, minus the number of blockships corresponding to the person in the check set. Now the check set means a union set or a disjoint set. we'll see what a disjoint set is. Union find or a disjoint set is a data structure used to represent a group of nodes which are connected to each other. For example, if you are given two graphs connected in a way like 1 2 3 4 and 5 6 7 8, they create their own two separate sets like 1 2 3 4 and 5 6 7 8. However, if we connect one edge of the first graph and the next edge of the second graph, this whole graph gets connected. So we merge the two sets and the union find deletes the previous two sets. Thus, we have this set which are connected to each other. Every union find data structure has a representative with it. This representative helps us to find that all the other members are connected to which set or are a part of which set. Now let's see how union set or union find help us to find the solution of our problem. So we'll first initialize three arrays. First array being the answer array. It stores the total number of friendship relationships and the total number of blocked relationships inside a set. We initialize first it to 0. The next array is father. Father array represents the check set representative which we have talked about earlier. We initialize that every node is a father of itself at the beginning, like C. At index I, index 1 is the father, 2 is the father, 3 is the father, and 4 is the father. The sum array contains the total number of members in the check set. As there is only one node in the check set as per now, in the initial stage, we have assigned it to 1 1 1. Now let's see how this three arrays changes as we take the input. So for the first S cases, we will take the input 1 by 1. The first input states that 2 is connected to 1. That means we can say 2 is a parent of 1. So in the sum variable, we know that the check set represented by the node value 2 has two nodes. So we have incremented to 2. At the father end, we have changed the 1's father to 2 now. And the answer, we have again changed it because 1 contains one friend and 2 contains one friend relationship. Now for the second input, 1 is connected to 3. So we can say 1 is the parent of 3, but 1's parent is 2 itself. So we can directly say that 2 is the parent of 3. And now we can see that at the sum array, the check set representative 2 has 3 value because there is 3 nodes in this check set. And at the father array, we have changed the 3's father value to 2. Similarly, we have incremented the answer variable. Now as per, we'll do the same thing up till S test cases. At the final, we'll see this. You can verify itself by doing it by using pen or paper. Now this is the most major part of the problem we have completed. The next part is pretty easy, which is the T blocked cases. For the T blocked cases, we have to just check whether the two nodes are a part of same set or not. If they are, we'll increment it, the value of answer. If they are not, we won't do anything. So the simple condition we'll check everywhere while taking the input for the T block cases is if the father of x is equal to the father of y. If it is, we'll increment the answer values. Now the major part of our problem is done. To find the answer, the required answer will be sum of father of I minus answer of I minus 1. Now let's see why. Sum of father of I, because father of I is the representative of that set. For example, for the first node 1, father is 2. Now the father is 2. The representative of check set with the value 2 contains 4 nodes. So 4 minus answer of I is 3. 3, that is 4 minus 1, which is 1. Minus 1, this minus 1 is because initially we declared that every node is a parent of itself, so we have to get rid of that condition too. Therefore we do minus 1. Therefore this comes 0. You can validate every value if you want to. So this is the pseudo code for the problem. First we initialize the global arrays. By initialize I mean to give them the initial values also. For example, answer I equals to 0, father of I equals to I, and sum of I equals to 1. Then we take the input of nst. Now for the first S lines, we know the first S cases are for the friendship relationships. So we increment the answer array and we find the union of X and Y. The union by the union I mean if both X and Y belongs to the same set, that means their parents are same. We do nothing. If they don't, we merge their sets and make them a single set, and we increment the sum value at that representative set. Now for the next t blocked cases, we it is very simple. We just check whether the parent of x is equal to parent of y. If it is, we increment the values of the answer array. Now all of the part is done. It's just we have to print the answer. So the answer is, for every ith node, the answer is sum of father of I minus answer of I minus 1, and we print the answer. So I hope so you can now solve the question. If you can't, don't worry, there is a GitHub repo link in the description of the video, which have solutions in many languages, so you can check out the solutions also. Thank you for watching our video. I hope you liked the video. If you do, please subscribe to our channel.